Nigel, thank you for joining us. We thought we'd do a series of podcasts at the MPC Alliance, just talking about, industry topics, academic topics, anything that's relevant to the community. Yeah, so this is our first one, and we're very happy to have you. So Nigel, of course, I think in this community requires almost no introduction, but I think he co-founded Real World Crypto, fellow of the IACR, co-founded Unbound Security, and currently advisor to, I think, enough startups that I need to be AI generated to count them on my fingers. Yeah, really, really interesting to hear your perspective and kind of your latest thoughts and experiences in the industry.
Cool.
Yeah. Uh, Anything you want to say before we
I think that's a
start?
good introduction, and yeah, I think the MPC Alliance does a great job. We kind of helped co-found it when it was when Unbound was around, so I kind of seen it grown, and so it's nice to see it still going and representing the industry.
Yeah, yeah, absolutely. Hopefully we'll continue to find ways to do stuff like this that sort of adds value and gives people a perspective on how MPC is doing in the market. So I thought I'd get into kind of the first thoughts. So it's been 17 years since groups began conducting well-documented deployments of MPC, like the sugar beet auction and so on. And the intervening years, we've seen a lot of these real world constraints associated with those deployments make it hopefully back into particularly the academic community and people who design protocols and evaluate them. And I just wanted to kind of hear your thoughts, having been in this community throughout this entire time span. Have you seen how, on the academic side and maybe a little bit of the applied side, how are people approaching protocols maybe differently? How are they looking at protocol, features like non-colluding parties, malicious versus semi-honest, those assumptions, as well as anything else?
Okay, that's
Yeah.
a really cool, interesting question. What I think the thing is, what I'd like to see in the next 17 years is people stop mentioning the sugar beet auction. That would be really cool. But I think.
Sometimes I like to mention the one I did with salary equity, but I wanted to have more humility. But yes,
Kind of like, yeah, we moved from sugar beet auction to Boston wage survey or
yes,
something like that. This one, yeah.
that
I
will
think
be
there's a,
progress.
yeah, I think there has been a lot of the academic community has, yeah, okay, how do I kind of explain this? There's these traditional security models that we had from the 80s, which is basically semi-honest and fully malicious. Okay, so. And what's been interesting since Sugarbeet, like over the last 17 years or however many years it's probably been longer than 17 years, it's more like 20 years, that we've now got different nuances. So I think really, if we look at practical schemes, certainly ones in MPC, ones which are based on linear secret sharing, there's almost no need um, to have when you've got honest majority, semi-honest security anymore. The overhead for running active with a bought security for honest majority is so trivial that you might as well do it. So I think active with a bought security is really the is like the minimum standard I think people should look at the moment in practical deployments. And we see that, I mean, so if we divide the MPC space up into those that are doing MPC for key management, like sort of the Unbound application, the thing that defense are doing, the thing that Fireblocks are doing, MPC wallets. I think there you're basically securing your secret. So you're securing your secret, and if something goes wrong, you really want to know something goes wrong because that means you've been under attack because you split your key into different places. So active with the vault security is, I think, the minimum you really should have there. If you look at MPC for data analytics, I think there you could actually argue that semi-honest security is enough. If you've got a bunch of hospital.
I often personally do, but yes.
You could argue,
Yeah.
but what I would say is actually the state of the art for linear secret sharing schemes is such that in an honest majority setting, the benefit of active with the bought security is one, it's for free, essentially. It doesn't really cost you much. And the other point is that it actually just allows you to cope with network failures. You know when there's a network failure. So it kind of gives you a little bit of extra support, but you probably don't really need it in the application. But I think, in an application, you're going to have to cope with servers going down. So if your protocol actually detects when servers go down or servers send something wrong, you know, then your protocol is actually providing a level of defense. So I think that's that. So I would say in the real world, active with the bought is the minimum, and that's actually been supported by the academic work. I think when you have fully malicious security or robust or what's otherwise called guaranteed output delivery, I think this is important in a number of applications. So I've been helping Zama with its MPC KMS for its fully homomorphic encryption stuff, and there it because of the use case, it really is important that the system never goes down. So it really is important that everything always goes through so we can cope with malicious parties interrupting the protocol, or we can cope with a party going down. So there actually, there was beginning to see robust protocols being actually deployed. So in Zama, when we do MPC, it's fully robust. It's fully the most complex thing you can think of. And then the other thing that we really haven't addressed in either the academic community very well or even in the real world community very well is the fact that networks aren't synchronous. That everybody's just
I was gonna, depending on where you went with this question, my next question was going to be exactly about that. Like when you answer that first question, does your mind immediately jump to kind of outsourced asynchronous type scenarios or more synchronous ones? I personally always advocate that we don't look enough at asynchronous, sort of the asynchronous nature of most business interactions out there,
yeah,
especially for the
exactly.
data
So
privacy
it's
side.
not just,
Yeah.
just business interactions. The internet is by inherently asynchronous.
Yeah.
So it's really important in protocols to try to limit your reliance on synchronicity. So I think that's really, and there has been a lot of work in the academic community on making really efficient asynchronous protocols, but I don't think they're practical enough yet. But in some situations, again, I go back to the Zana KMS, is that most of the protocols there we try to use are asynchronous. So we limit the amount of synchronicity we require, and we try to put as much padding in place to make sure, padding and controls in place to make sure that the fact that the internet isn't synchronous, it doesn't really affect the protocol enough. And then there's other aspects that have been looked at in the academic world, which I don't think are really um, caught on so much or haven't actually caught on so much really in the academic world, and also haven't really caught much on so much in the practical world, in that there are other ways of skinning the MPC cat. Is we kind of think of all the parties communicating with each other, but there's been things to do with committees. There's things to do with movable adversaries. We did some stuff recently. It was an Asia Crypt, I think, a year ago or 2 years ago, with MPC with Starlight networks, which was actually motivated. Well, we kind of started thinking about it because of someone did an MPC wallet with a similar architecture, and we thought, oh, could you actually do this for general MPC? And it turns out that's actually quite useful because if I'm deploying MPC in a corporate and I have to communicate with all the other parties, and these parties might not actually be known until the point of the computation, that's really hard because I have to manage who's going to pump the holes in the firewall to specific parties, etc. And the management can be quite difficult. So actually isolating who is providing nodes for you to actually engage. So when I do an MPC protocol, I don't know who I'm going to do it with 3 hours in advance, but I do know who's going to be the service provider, who's going to be the gateway for the MPC protocol. So by using this gateway, we can actually utilize the gateways to actually provide components for the protocol, which actually allows us to have different types of MPC protocol. A kind of a weird thing that we had with this kind of Starlight network is that broadcast is actually cheaper than point-to-point communication.
Hmm.
which actually then flips on its head the type of MPC protocols you could do. So I don't think, things like that have been having
Hmm.
architectural things that occur in business and those architectural aspects, mapping them down to the mathematical protocols and then investigating, what does that actually mean? Does it give us any benefit or is it all just negativity? So it's a kind of
Right.
that's I
Actually, a
really
question, yeah, a question about that because I haven't looked into that myself. Is that kind of, I mean, it presumably has impacts on whether you can have censorship resistance. I mean, because cause there's a layer that's more centralized in that kind of
yeah. So
architecture,
the
right?
idea is that you kind of that the centralized layer you replicate just like you would on a blockchain. So
I
in some
see.
sense,
Okay.
the centralized layer is replicated, and you can take an on. So you have the parties engaging in the MPC. They're communicating
Hmm.
via a centralized layer, which is essentially an MPC relay,
I see.
which is multiple parties. But unlike a blockchain, you don't need consensus between them
Right.
because each party because I'm connecting to two relays. I know whether they're you send me
Hmm.
some data, you send me some data. If they're not the same, one of you is lying. I don't need to have
Yep. Yep.
consensus so I can work out
Yeah.
correctness in itself. And
Yeah,
so
that's an interesting separation of concerns that again, I feel like I'm sure it's getting better, but certainly even probably 5 years ago, I feel like there wasn't enough attention to these kind of real world layered
yeah,
architectures and how things interact. And that is something that, yeah, I would certainly encourage everyone if you're working on. Just as I encourage people to look at asynchronous scenarios, I think that's definitely something where there's just not enough out there if you're actually trying to solve a business problem.
yeah, and I think like I said, the interesting thing we had is that actually it just completely flipped
Yep.
what was considered inefficient versus efficient. And the thing that you really want, which is broadcast, actually becomes much more efficient than communicating individually to different parties, which means that the type of protocols you could implement change dramatically.
Yeah. Yeah, definitely. Yeah,
That's
it's very
fun.
interesting. Yeah, this it's and I think yeah, hopefully, we'll continue to see a more diverse array of and variety of protocols in the literature because
Yeah.
it's definitely there's definitely a variety of business problems. And that kind of brings us maybe a little bit to another topic that maybe is a natural extension of this, which is I always describe a kind of optimism that I myself have been guilty of in this community, where we think to ourselves, "Oh, we'll build a compiler for our protocol or a library, and then people will just start using that compiler and they'll write their data analytics workflow using that and so on." But I think at least in my own personal experience, what I found is it's a lot harder to write a compiler someone will use because we take for granted the decades of work that existing communities have put into, for example, if you look at R, or if you look at even just Python and NumPy and
Yeah.
SciPy and Pandas, that's a tremendous amount of work by multiple communities, all interacting with one another and with real business and academic and other use cases and government use cases that they're trying to address. So I'm just curious, given how many startups that you're advising, kind of what you see across the board in how companies are approaching this gap that basically needs to be filled so that the right protocol can be chosen or the protocol can
Yeah,
have
I
the
think
right
I think
parameters.
I think there's different issues there. There's one is the right protocol. There's two is how to deploy it. Because deploying MPC protocols is difficult because you need to get multiple parties to agree. And that's there's always you have to have multiple parties agree on what they want to compute, how they want to compute it, where they're going to compute it. So that's really quite hard. And then you've got the how you program it, so the developer experience. So you have deployment. So with MPC, you have a particular problem. You have a deployment problem, we have a developer programming problem, and I think if we take the developer programming problem first, I think a lot of companies, whether they're in ZK, FHE, or MPC, they kind of make an assumption, or also academics also, is that you can learn my new domain-specific language. Yeah, no, no,
Yeah.
no, no. Yeah, this.
I mean, if you look at my own history with programming languages and being in that community, is people make that assumption even just about their own programming language, let alone
Yeah,
whether it's useful for something. So
yeah.
yeah, it's definitely something that,
I
everyone, the
have my,
N
I have
plus one problem.
Yeah, yeah, yeah. Computer science departments, when they teach languages, have the language wars. I think, everyone likes their own favorite language. So if you could have the ability to create your own language, you will, and you'll love it. Um, but not what developers want. Developers want something that's really seamless. So I think, if you look at some of the companies I've been talking about, so Ligero on the zero knowledge side, they just take standard WASM. You could just write any old shit,
Mhm.
right? Compile it into WASM, and then they apply their zero knowledge stuff over WASM. So they basically have, their product is something that takes WASM and turns it to zero knowledge. So as long as you can compile the WASM, you're done. So you have Rust, C, whatever. Web, you can do it in the web, whatever. So that's really cool. If you look at Zama, they have the FHE side. So they basically have a Rust FHE library, and they have um, the concrete, which is like an extension to PyTorch and ML type thing. And there, essentially, what it is that the developer experience is essentially what they're used to, plus some syntactic sugar. So if you so instead of have a uint 64, you'd have a encrypted uint 64, and then you kind of, you just kind of take the sugar, and you can and then it all just works well. So the developer experience you should be able to take a developer who knows the underlying language, and be able to turn them into a developer that can make secure versions of their code faster.
Mhm.
Then you've got the issue is that obviously sometimes the algorithm might have to change, which is, the problem with if statements is the obvious one. Yeah. Do you really want data oblivious control flow and things like that? Which in some sense, if you take away the difficulty of learning a new language, you can actually make it clearer to the developer what the issue is with the control flow in some sense, because you've solved part of their problem of learning what to do. You've solved, so they just have to concentrate on the thing that's actually algorithmic. So that's one side. And then on the other side, it's the system, how you deploy, how you get this to deploy. And I think in terms of MPC, that seems to be the hardest thing. And because I remember before we founded Unbound, we had this meeting of like all the MPC practitioners in the world was at Dargstall, and every time we sat down, we're going like, yeah, but you have to get. So we go, but the academics would go, yeah, but we just get two hospitals, and they want to share their data, and it's
Yeah.
going to be great for the world, and there's obviously great utility in this.
Famously easy to deploy vendor solutions, vendor IT
Yeah,
solutions into hospitals.
and then you go like, yeah, one, it's really, really hard to deploy into hospitals. Two, you now have to get two hospitals who understand what the hell you're doing before you've even got to that. We're going to deploy IT into hospitals. You actually have to get two hospitals to understand what you're doing at the same time, because there's no point selling the stuff to one hospital and then going around looking for another hospital to actually for it. You have to simultaneously sell to two people. So I think with MPC for data analytics, that's a real concern. And I think this was Yehuda Lindahl's great insight when Unbound was founded. I mean, I remember the meeting. We were in a hotel in Tel Aviv above the beach, and he said, "I've solved your problem you were talking about with having to find two people at the same time to do an MPC protocol. You just find one person and you split them in two." So in some sense, what it is the reason why MPC works for MPC wallets is because divorce is
Mhm.
easier than marriage.
Mm.
Yeah,
That's
you're
an
based.
yeah, it's an interesting insight about the product market. One of the most successful, I think, product market fit stories so far for MPC is Web3 wallets.
Yeah, it's divorce.
Yeah, yeah,
You're divorcing the secrets rather than bringing the secrets together.
yeah. That's an interesting perspective, definitely.
And I remember, yeah, I remember. As soon as he said this, it was just like apparently he saw the dollar signs light up in my eyes
Mm.
when Yehuda explains to me. It was kind of like, wow, that's amazing. Yeah,
Yeah, it's definitely, now that I think about it, in a way that has been some of the success, I think, even in the advertising space, because most of the time it's not the case that you can find even two parties in these kinds of scenarios, but what you can find is parties who don't want to be liable, to have liability for the data that they hold, and most of the motivation, which has had some air taken out of it recently with Google's announcements that they're going to deprecate privacy sandbox and they're going to abandon sort of removing cookies. But at the time, a couple of years ago, when there was a lot of traction in that space, most of the motivation was more about I would like to not be perceived as a
Yeah.
company that collects all of the data, so I would like to, yeah, not be subjected to that scrutiny. So that's a good point. Actually, yeah, maybe that's something we can kind of almost report as an observation from the first 10 to 20 years of MPC, is that it's easier to get one party to split itself into two than to find two parties to work together. So
Yeah.
quite profound insight. A little bit related to that question, yeah, could you comment perhaps on kind of more broadly what you feel are the product market fit kind of opportunities maybe moving forward that you're seeing on the horizon, if there are any, in addition to kind of wallets and those kinds of
Oh,
Web3 use cases?
interesting question. I think there's a case with wallets. I think there's a case with arbitrary controlling keys. I think that's a really, like, well, just not just signing keys, but keys that enable systems to, general KMS keys. And there you've got, like, I think the wallets are a very specific example where um, it's your key, and if you lose it, it's your problem. And if there's a problem with one of the servers, it's your problem. And therefore, it's in some sense everything is your problem. So that's kind of
It's
easy.
why Johnny can't encrypt, which I always love
Yeah,
referencing.
yeah. But it's still your problem. So actually, the protocols can actually be simpler than when it's I'm controlling a key but if access to this key drops, it's everybody else's problem.
Mm.
Because the key is, so this is what happens with the Zama KMS, is that Zama doesn't want to hold the key, but if the key becomes unavailable for some reason, that's everybody's problem. So in some sense, there you have to have much more resilience. That's why you need robustness in the protocol. So that's why so even when you split the key up, you have, depending on the use case, you would have different backgrounds, different controls in place, different MPC properties that you would need. Um, I think the data analytics one is kind of interesting, but I think the problem is people have phrased the value proposition around privacy and security. And let's face it, no one cares about privacy and security, right? So in some sense, it's not about I want, I've got some, this is what I kind of normally say is if you have some data analytics problem, and your problem is that you're having to see the data, and you say, I don't want someone to see the data, therefore I'm going to apply TEs to it, I'm going to apply MPC to it, I'm going to apply FHE to it, I'm going to decide whatever I want to apply to it, zero knowledge proofs to it. Often it's not, the technology will not solve your problem, because a data analytics pipeline is almost always starts with someone, data analyst, has to look at the problem and work out what the hell we're going to do. And actually, the MPC and the zero knowledge and the FHE and the TEs only are very useful at the very end stage, where you know what you're going to do. And this is the algorithm I'm going to do, and I'm going to do it for all the data coming in. So often, if you have like exploratory analysis data, which is kind of in the scientific domain, you have drug data, you have medical data, you have drug trial data, often the analyst doesn't know what they want to do. So actually we're going to make this so much more secure by making it all private, means you're actually going to make it unusable. So I think why this is not really taken off is because if you phrase it as this is a privacy, a security issue to do with data, it kind of implies people start thinking, okay, I'm only looking at applications where I have data, someone's got the data, and I want to make sure that it's secure. Whereas I think that the real usefulness comes in applications where I can I can do something that I couldn't do before. And this comes down to performance. It's also how it comes to performance. Because if you go to someone and say, we're going to take your existing application and we're going to make it 1,000 times slower by applying MPC to it, that's not a good value proposition. Whereas if you tell someone you can't do something now, but if I use secure compute, I can do something, that's an infinite speed up. No matter how slow the secure compute is, it's an infinite speed up on where you started from. So there, I think applications where it's regulatory, so for example, we have applications in the sort of anti-money laundering, credit risk things where you're not allowed to share data, but there is value in sharing data. And you can extract that value, so you can gain value by sharing data, and you use the secure compute to be able to share data where you wouldn't otherwise do it. So it's not taking an existing application and securing it. It's going, here's a new business model, here's a new revenue stream that you can enable from secure computation that you didn't have before. And I think if you look at, you know, the kind of some of the press and some of the company releases around the who have been doing the secure data analytics using MPC, Roseman Labs, Roseman Labs, there's ones in the one in Switzerland. I can't. Oh, I've forgotten its name. Brain dead. With the hospitals in Switzerland, they've been doing stuff which have. It could come to me a minute. I'll do
Wait, is
it.
it with TEEs and decentric, or are you thinking of something
No,
else?
this is another one. Yeah, there's another one. No, I can't remember what it is.
Yeah, okay.
Um, I apologize to you if you're listening. I'm really sorry.
I'm sure there aren't that many
There
if
are a
one were
few,
to
yeah.
Google. Yeah.
There's a few, and there's and a number around. They're all kind of about the ones that seem to be successful, even if they're just proof of concept ones, are ones which are enabling new business models or enabling you to do something you didn't do before. It's not taking an existing application, and so I think. And people, when you start thinking about privacy, people start thinking about existing applications rather than new ways of doing things.
Yeah, and this is where I think it's, and this is where, members of the MPC Alliance do and should continue, and I would encourage anyone is to inform regulatory bodies about these technologies.
Yeah.
So recently there was a decision by the European Court of Justice that was quite encouraging, where they actually, for the first time that I'm aware of, and that might just be my own lack of awareness, but they recognize that data that is for our purposes, usually it's encrypted, but here it was about pseudonymized data, which of course is a lower bar. It's not the case that when you have that pseudonymized data, it's the same as if you actually have in the clear data, because there's certainly been arguments proffered in the past that say, even if you have data that's encrypted and you don't possess the key, technically you can take the action of giving it to the person with the key, and therefore you still have
Yeah.
responsibility for it. So it's encouraging to see regulators start to
I
recognize
think
that
I
there
think
is
it's
a spectrum there.
a bad wording of GDPR, because if you the GDPR talks about pseudonymized data, and if you read between the lines of when it talks about pseudonymized data, it's talking about the Netflix attack. It's
Hmm.
talking about you have one database which you've anonymized it, and if you combine it with another database, you reveal information. It doesn't mean I have this one database, and if I reveal one key, it was really separating encryption from pseudonymization, and I think the lawyers don't like that, and so so some lawyers and some jurisdictions kind of conflated pseudonymization with secret sharing with encryption, and I think that's really held back, given that Europe is so advanced in MPC startups. It's really held back European startups in this space because all the lawyers would just go, the GDP doesn't allow you to do this. So
Yeah.
that's been a problem.
I can sympathize because I've been on some of these panels, and I think obviously their challenge is they do want to compartmentalize it. From their perspective, this is one issue of many that they have to contend with, and so it is tempting to compartmentalize these new technologies that are unfamiliar, and in many cases there isn't a lot of real world experience interacting with them. So that's how I feel, kind of, part of the reason why we kind of tend to drift that way. But I think that the good thing is that those communities are engaging
Yeah.
with the pets community. So hopefully that will continue to improve.
And I think
So
the
just
other
yeah.
problem with GDPR is it's created a bonanza for lawyers, not technologists.
Well,
So I think
uh,
actually, if it was a bit more risk-based, it would be more, you would say this is the risk of doing this, and this if I have this technology, it reduces my risk. That would be better than the prescriptive reading, the legalese, and just giving the lawyers jobs.
I have to say, yes, a large fraction of the revenue that I've personally been involved with in MPC has been handed right off to the lawyers in the background
Yeah.
to get things done. So it's definitely been they should encourage us because I think it has been profitable at least to the lawyers that I've had to pay. So one last kind of maybe question, a little more broad, but anything just you've witnessed recently that is either particularly surprising or exciting, or that you just would like to comment on?
Oh gosh, I think the coolest result of the year by a long way, it's not in NPCs, in the zero knowledge space, was that you have these zero knowledge protocols, yeah. So
Mm,
think of a standard Sigma protocol for Schnorr signatures. So what happens is I want to prove knowledge of a discrete logarithm. So I have G to the X, I send G to the R over, I hash the statement along with the thing, and then I send a value coming back. And that's like a standard Fiat-Shamir transform. It's what allows us to do signatures and stuff like that. And you can think of the Schnorr protocol as a zero knowledge proof of knowledge of the discrete logarithm. Tick.
mm,
So what we've done is we've made a non-interactive zero knowledge proof of knowledge of the discrete logarithm by using the random oracle model. Tick. And so surely we can do the same for arbitrary zero knowledge proofs. So we can take a zero knowledge proof of an arbitrary statement, send it along, and would be an interactive proof normally. And then what we do is we just hash everything, and then we can apply the Fiat-Shamir transform when we get a non-interactive proof. Cool. But it was proved, I think in January this year, by Rothblum, that this doesn't always work because if the statement you're proving is super complex, it could contain the hash function itself that you're evaluating when you do the random oracle.
mm,
So it turns out that this you could actually prove false statements using the random oracle model. So this is and the proof of this is super simple, but not simple enough for me to explain it here. Um, but the basic problem is that we've taken this very simple thing that we originally applied in the 80s to standard little identification protocols, very simple zero knowledge proof protocols, and we're now applying it to zero knowledge proof protocols where we can prove anything. In particular, you can prove inside the protocol that you've got the hash function inside the circuit of the thing you're proving.
mm.
And that was just like super interesting, super surprising, super simple result. Um, but yeah, that was kind of mind-blowingly interesting. I think that's certainly the coolest thing I've seen this year.
Yeah, that brings to mind a lot of questions in my this kind of almost encourages you to go back and say, ooh, maybe we should stick to just linear secret sharing. Because now that when I think about the mechanics of the stacks of cryptographic assumptions and primitives that are sometimes sort of put together in a protocol, it's difficult to keep track of everything and how it interacts. And that's definitely
Yeah.
a
It's
warning
really a
sign.
case of, you build things up slowly, and then someone notices actually you've built it up so high that
Yeah.
you can collapse it back down to the bottom. It's just, yeah, it's a really cute result, which I suggest everyone look up because it's 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 not a complete no-go for proving complex zero knowledge statements, but it does show that you have to be a bit more careful.
Yeah, I mean, composition in general, right,
Yeah.
is a huge thing to we haven't even gotten to the level of success where we need to worry about it almost, but at some
Yeah.
point, when especially if consumers are all using several different protocols from several different vendors at the same time and relying on their privacy being protected by all of them, who knows what's going to happen if you jointly, particularly because, for example, let's say that you're using the same biometric source material for multiple protocols, what happens in that case? So it's, yeah,
Yeah.
these are all good questions. Yeah, very interesting. Cool. Well, yeah, this was a great conversation. I think there was a lot of interesting insights and thoughts there that are worth pondering. Um, and we really appreciate you joining us today and sort of sharing your experiences. And again, we look forward to doing more of these, and hopefully, we'll continue to grow this community, educate people about MPC, and move forward and succeed together. So, thanks again. Really great speaking with you today.
The Swiss company's tune insight, I remembered now.
Ah, yes, I remember that name now as well. That's great. Okay, we we
Apologies
we
to Tune
we
Insight.
we've jumped out of the frying pan on that one. So that's great. Yeah, cool. All right.
Thank you very much.
Yep. Thank you.